You were able to?
Yes, ma'am, I was able to. I did with the help of the definition.
Okay, okay. No. Okay. See, I think we had discussed, I think I told you about it, if I'm not wrong.
Yes,
I
ma'am, you
think because
told
I
me about
am
it.
able to recall it, we had some discussions on that. If not, then
Yes.
okay. I'll look into that question. Don't worry. Okay.
Okay, ma'am.
So now tell me, where did we discuss it? Till what? Okay, we had
We were
started with the okay, fine, fine.
solubility. From that we have to
Okay,
start.
fine. Okay. So just a quick revision of all of this. Okay.
Okay, ma'am.
Otherwise, how was the test, Harshita? Was it okay?
Yes, ma'am, the rest of the questions were easy.
Okay, fine. See. Okay. So we started discussing about a solution. So mixture is obviously two types, homogeneous and heterogeneous. We are discussing the homogeneous mixture. Why? What do we mean by homogeneous mixtures? Mixtures in which there are two or more than two pure substances which have dissolved into each other properly. Yes. If they have
Yes, ma'am.
dissolved into each other properly, there is no clear distinction between the different type of elements or substances. Yes.
Yes, ma'am.
There is uniformity all throughout. There is even distribution all throughout. Right.
Yes,
Now,
ma'am.
and the homogeneous mixture is referred to as a solution. Is referred to as a solution. A solution has got two parts. What are those?
Solute and
Solute,
solvent.
solute, and solvent. Okay. Solute generally is the part of the solution which is less in quantity. Solvent
Yes,
is the
ma'am.
part of the solution that is greater
More
in
in
quantity. Right? Fine.
Yes, ma'am.
Now we generally think that solution is generally in the liquid state. Okay. But a solution can also be in the solid state. Example. What is the example for a solid solution?
Is
You know it. Mm-hmm.
solid.
Metal gives you what? Metal and metal mixture.
So it gives an alloy.
Exactly. So alloy is what? It's a solid
It's a
solution. Yes,
solution.
it's a solid
Okay.
solution. Yeah. Gaseous solution we have. What is that example for gaseous solution?
It's air.
Wonderful. It's here, right? So we have
Yes.
solutions in all the different three states. It's not necessary that they have to have the solution in the liquid state only. Okay.
Okay,
And
ma'am.
one point to be very important here, Harshita, is that the state of the solvent, the state of the solvent determines the state of the solution. The state of the
Okay.
solvent determines the state of the
Solution.
solution. Is it clear?
Yes, ma'am.
See, now we can obviously have solvent in all three different states, solid, liquid, and gaseous. We have discussed two cases wherein the solvent is also solid, that is alloy, wherein the solvent is also gaseous, that is air. Fine. Now at your level, we generally have the solvent in the liquid state. What is it? The liquid state. Okay. We are going to deal
Okay.
with the solutions which have solvent in the liquid state. Is it okay?
Okay,
Now,
ma'am.
when the solvent is in the liquid state, the solute for this solvent, for this liquid solvent, can be a solid, can be a liquid, can be a gaseous state. Is it clear?
Yes,
Fine.
ma'am.
Give you some quick examples and then we'll try to understand. Okay? If I say, we have soft drinks, you understand soft drinks or aerated drinks?
Yes, ma'am.
What are these? So is this a solution? Yes, clearly it's a solution. It's a mixture of two or more than two components, but in a homogeneous manner. Yes,
Yes, ma'am.
in a homogeneous manner. So, Acha, what do we mean by homogeneous manner? If I say here homogeneous manner, what happens here? Homogeneous manner.
So both the components mix uniformly and
Yes.
they are constant.
Yes. Can I say that it forms a one-phase solution? One-phase solution. You understand phase? There's no difference. When we say that there is no clear distinction, that means there is no difference between them. The solution is in one phase all throughout. You understand the
Yes.
term phase? Understand that?
Yes, ma'am.
So at
Yes.
times you might also find this written for the homogeneous mixture. That means homogeneous mixtures, they have one phase solution. Okay. Whereas the
Okay,
heterogeneous mixtures, they are two or more than two phase solutions because no dissolving takes place there.
okay, ma'am.
Is it okay, beta? So
Yes, ma'am.
soft drinks, okay, they are homogeneous mixtures. They are one phase solutions. We can clearly not not differentiate between the different substances. Fine. Now,
Yes,
what is the state of this soft drink?
it is in liquid.
Liquid state. Obviously, the solvent is also in the liquid state. Yes.
Yes, ma'am.
What is the solute for these aerated drinks?
So it is air.
Very good. Very. It is in the gaseous state, not air,
Yes,
not necessarily
the
air.
gas
Actually, when we have the soft drinks or the aerated drinks, generally it is the carbon dioxide, right?
carbon. Yes, ma'am.
So it is in the gaseous state. Is it clear? So here the
Yes,
solute is in the gaseous state, solvent is in the liquid state, overall the solution is in a liquid state. And this is an example of a solution. Is it clear?
yes, ma'am. It is clear.
Any confusion here?
No, ma'am.
Next example, if I tell you, let's say we have sugar, okay, or salt, whatever we have, and we have water, sugar, salt, water, okay. Clearly,
Okay,
it's
ma'am.
a solution. It's a
Yes,
solution, one phase solution, no distinction between different substances. See, beta, sugar is a compound. Sugar is a compound. Why is sugar a compound? Water is a compound. Yes, you know it.
yes,
Salt
ma'am.
is also a compound. NaCl. Why is sugar a
Yes.
compound?
Uh,
Is sugar a compound? If I ask you, is sugar a compound? Yes or no?
yes, ma'am. It is a compound.
And why? Why do you say that?
It's it's because they are
Mm-hmm. Just think. Because you should have questioned me, ma'am, why, like, how do we say that sugar, salt, water is a mixture? For it to be a mixture, clearly sugar should be a compound. Sugar should be a pure substance or an element, whatever it is.
yes, ma'am.
Is sugar a pure substance?
Yes, ma'am. It is a pure substance.
Element or compound?
Uh,
Okay,
it is a compound.
fine.
Um,
Mm-hmm. They call the process of photosynthesis. Or in that, you must have learned that something called as glucose.
yes, ma'am. Glucose.
Glucose is sugar.
Yes, ma'am. It is sugar.
And what is the formula for glucose?
It's
C6, H12,
H12.
O6, something like this.
Yes, ma'am.
So is sugar a compound? Yes, it is a compound.
Yes,
It
ma'am. It
has
is
a
a
fixed ratio of the elements that participate in it. Okay. It has a fixed
okay.
ratio and a fixed composition by mass. Is it clear?
Yes, ma'am.
Okay. So see, sugar or salt water solution. It's a solution. Okay. Why a solution?
Okay.
Because it's a mixture, because two different pure substances are mixing together, dissolving together, therefore a homogeneous mixture. If a homogeneous mixture, clearly a solution. Okay. If it is a
Yes.
solution, there would be a solute and a solvent. Yes. What is the
Yes, ma'am.
solvent here?
Solvent is uh, the sugar or salt.
Beta, solvent is water. See, water is in the greater quantity. Yes, we do not mix a half glass full of sugar and we mix some teaspoons of water in it. No, right? We take a
No.
glass full of water, or and then in that we mix some half teaspoon or 1 teaspoon of sugar or salt. Okay. So
Yes,
sugar
ma'am.
and salt, they are the solute, and water is
Solute
the
and
solvent
the
here.
solvent.
Okay. The
Okay, ma'am.
state of the solvent here is what?
It's
Liquid.
it is in
Beta, what?
liquid.
Yes. And what's the state of solute?
It's solid.
Very good. So it's an example of a solid solute dissolving in a liquid solvent to give you a liquid solution. Clear?
Yes, ma'am. It
Any
is clear.
problem in this?
No, ma'am. I got it.
Next, we have tincture of iodine. I don't know if I've discussed this with you or not, but tincture of iodine. Okay. So tincture of iodine, it's a disinfectant. Okay, it's a solution which is used as a disinfectant.
Okay, ma'am.
So see, tincture means alcohol. Tincture means alcohol.
Alcohol.
It is a solution in which iodine, some amount of iodine is dissolved in the alcohol. Okay.
Okay, ma'am.
Clearly, it's a solution. Why is
Yes,
it a
ma'am.
solution? See, alcohol is a pure substance. It's a compound. Alcohol is a pure substance because it's a compound. Iodine is a pure substance because it's an element. Okay.
Okay, ma'am.
Clearly, two pure substances are getting mixed together.
Yes, ma'am.
Therefore, a mixture.
Yes,
Yes.
ma'am.
Homogeneous mixing. Okay.
Yes, ma'am.
Therefore, a
Yes.
solution. Now, if it is a solution, clearly it will have a solute and a solvent. Quickly tell me the solvent and the solute here.
The solvent is alcohol and solute is iodine.
Oh, wonderful. What is the state of alcohol, beta?
It's in liquid.
What's the state of iodine?
Solid? No, it's in liquid. Liquid state.
Solid. Solid.
Solid.
Okay. That's it. So solid
Okay.
solute mixed in a liquid solvent to give you a liquid solution. Okay. I
Yes,
hope
ma'am.
there's no confusion in this.
No, ma'am.
Any point, beta, that's not clear?
It's clear for me, ma'am. I
Fine.
understood it.
Wonderful. Coming on to the next point. The next point that I wanted to discuss with you. Okay, first, beta, quick confusion here. That is, I don't know what definition did we write for alloys. Mixture of two or more. It was elements and not metals. Actually saw that while going through the notes. It was elements and not metals. That means it can also be metals or it can also be non-metals. Okay. Generally,
Okay.
it's the metals taking place together, but at times it can also be non-metals. Therefore, two or more elements. Okay, beta.
Yes, ma'am.
Fine. The next point. Beta, related to this is some additional part that is miscible or immiscible liquids. You must have heard of this.
Yes, ma'am. I have.
What is it? Any
Um,
idea?
miscible means the liquids that mix with each other,
Fine.
and immiscible means the mixtures that don't mix with each other. So,
Very
example
good.
like oil and water.
Okay, very good. So, miscible, can I call miscible liquids as a solution?
Yes, ma'am. It is a
Because
solution.
if they are getting mixed together properly, that means the dissolving is taking place here.
Yes,
That
ma'am.
means a solution. Fine. Now, if in the miscible liquid, beta, can you give me some example?
Miscible milk and water.
Milk and water actually is not a solution. Milk and water becomes a colloid because no actual dissolving takes place. Okay.
Okay. So the
Alcohol and water.
alcohol and iodine.
Okay, but that's not a that's not a liquid iodine. Yeah.
Okay, ma'am.
Alcohol and water, beta. See, alcohol
Yes.
mixed in water. Okay. So this is a miscible liquid. This is a solution. Okay. Can you tell me here what is the solvent, what is the solute?
Yes, ma'am. So, water is the solvent. Alcohol is the solute.
Very good. Can I call it as an example of a liquid solute mixed in a liquid solvent to give you a liquid solution?
Yes, ma'am.
Clear?
Yes, ma'am. It is clear.
Fine. So this was the example that I wanted to discuss with you. Coming on to the next point, that is, tell me, did we discuss the properties of the homogeneous mixtures, beta?
Yes, ma'am. We did
We
discuss
have
property.
discussed. Okay, what are those quickly? Tell me.
So it has a uniform mixture, and it cannot be seen through the naked eyes.
Why? What is the size of the particles for a solution?
It is a 1 nanometer.
It is
Less
less
than
than 1 nanometer.
less
It
than
is
one.
not 1 nanometer, it's less than 1 nanometer. Yeah,
Yes.
very good. Then, what is the relation between a nanometer and a meter?
Mm, yes. Okay,
Okay.
ma'am.
1 nanometer is equal to 10 raised to the power minus 9 meter. Okay, so very,
Minus
very,
9.
very small in comparison to a meter. Okay.
Yes, ma'am.
Then what are the properties?
The properties.
Mm-hmm. You told me two. Uniformity, that is homogeneous. That is why it is a homogeneous mixture.
Yes, ma'am.
Second, it cannot be seen through the naked eye, right? The
Yes,
correct sentence should be the particles of the solution cannot be seen by a naked eye. Fine. Because
naked
the
eye.
size of the particle is very small, that is less than 1 nanometer. Okay, very good. Any other property?
We cannot separate them through the physical process.
Okay, okay. And why can't we do that?
It's because they are the homogeneous mixture are chemically bonded.
Listen, Harshita. Harshita, revise that point. Recall that point. Again, say that point.
Uh,
Listen, beta. It's a mixture. No chemical bonding has been taking place except in case of alloys.
okay, ma'am.
Yeah. No chemical bonding has taken place here in case of mixtures. Mixtures, they are physically bonded. Had they been chemically
Okay,
bonded, it would result into a compound. Yes.
okay, ma'am.
Even though
Yes,
it's a
ma'am.
homogeneous mixture, does not mean that chemical bonding has taken place. If it's a
Okay.
homogeneous mixture, it means they are properly dissolved into each other. The particles of the solute and the solvent are dissolved into each other. Yes?
Yes,
Is it clear,
yes,
beta?
yes, ma'am.
Therefore, they can be separated out by physical processes of separation, like fractional distillation, which is a physical method of separation. Clear?
Okay, ma'am. It
Okay?
is clear.
Yeah. But what you were trying to say, I think, is that they will not settle, the particles will not settle down at the bottom of the container after they are left undisturbed for a long time. That is because they are actually dissolved in it and the mixing has actually taken place. Is this what you were
Yes,
trying to say?
yes, ma'am.
Therefore, the process of filtration cannot be applied here. Okay.
Okay, ma'am.
Filtration is not possible here because no deposition of the particles at the bottom of the center takes place. Okay. At the bottom of the container takes place. That is the point. Is it
Okay.
clear? Tell me, are these two to 3 points clear? Do not
Yes,
get
ma'am.
confused in them.
Yes,
Right?
ma'am. It is clear.
So therefore, the solutions are referred to as stable mixtures. What? Stable mixtures.
Stable mixture.
And what do we mean by stable mixtures or a stable solution?
They're uniformly mixed.
Mm-hmm. Beta, listen. Stable mixtures or solutions mean they will not get settled if they have been left undisturbed. Okay, that is what we mean by
Okay.
stable. They are stable
Yes.
because they are actually like that even after they have been mixed properly. Yeah,
Okay, ma'am.
but
I
I
got it.
think we discussed it. Yes, we have discussed a stable mixture. Okay, no worries. Is it clear now?
Yes, ma'am. It is
Okay,
clear.
the fourth one was no Tyndall effect is shown by the solutions. What is a Tyndall effect?
The like the beam of light, like when it
Fine. See, beta see. If this is a if this is a container having a solution of sugar and water, okay,
it's
sugar and
scattering of the light.
yes, very good. This is scattering of the light.
Okay.
What happens here? The particles are so small that they have actually dissolved into each other. Yes. When the
Yes, ma'am.
beam of light comes here, the particles, because they are so small, will not scatter the light. Yes.
Yes, ma'am.
If the light is not scattered, we will not be able to see the path of the light. Okay.
Okay, ma'am.
And this scattering of light to show the path, to be able to see the path of the light is called as Tyndall effect.
Tyndall
Therefore,
effect.
solution do not show the Tyndall effect. Is it clear?
Tyndall. Yes, ma'am. It is clear.
If I ask you the reason why Tyndall effect is not shown by the solutions, what will be the answer?
It's because the particles are very small.
Very small. And they have actually dissolved into each other. Very good. Very good. Okay.
Okay, ma'am.
All of it clear till here? You haven't
Yes, ma'am.
noted down the properties. Do you want to note it down or should we move ahead?
I noted it down, ma'am.
Okay,
You
wonderful.
can go
Now,
ahead.
see, now coming on to the important topic called as concentration of the solution. Okay.
Okay, ma'am.
Concentration of the solution. What do you understand by the concentration of the solution?
Um,
See, if I just ask about the word concentration, okay, just about the word concentration and not the mental concentration, not that, the chemistry part, okay, concentration. What idea do you get from the word concentration? Can I say I get some idea about the quantity of something when I hear about its concentration? Let's say the concentration of this is very high. That means clearly the quantity would be more.
yes, ma'am.
Can I say somewhere that we need to learn about the concentration? That means the quantity of the particles of the solution. Yes or no?
Yes, ma'am.
Right? So just try to understand it that way. In simple terms, it will somewhat refer to quantity. Okay. Now see, that means
Okay.
the amount concentration of the solution refers to the amount of the solute in the solution.
Okay, ma'am.
In the solution. See, it can be actually shown by three different terms. Dilute, the solution can be diluted, it can be concentrated, okay, or it can be saturated, or it can be saturated.
Saturated.
So diluted and the concentrated terms are very comparative terms, okay. As in, I can call one diluted because the other one is concentrated. Yes or no?
Yes, ma'am.
That is not the case with saturated. We are going to understand saturated again. I don't know whether we discussed it properly in the last class or not. So we'll start it here properly. Saturated, okay?
Yes, ma'am.
Let's see what happens. If I say there are two water molecules, okay? There are two water
Yes.
molecules. And if I say some sugar is dissolved in it, some sugar is dissolved in it. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Leave everything. Just can you tell me within these two particles of water, I think no more than 10 particles of sugar can be dissolved? Yes or no?
Yes, ma'am.
Right? If you sit in a car that has a maximum capacity for 7 people, that has a maximum capacity of 7 people. If I say
Yes.
that, can you adjust the 8 one? What will you say? Yes or no?
No, ma'am, we cannot adjust.
No. Clearly, the capacity is already full. Yes,
Yes, ma'am.
the capacity is already full. In this case, two water molecules can hold a maximum of 8, or 10 sugar particles. Yes, it
Yes,
cannot
ma'am.
hold any other sugar particle. Therefore, this is a saturated solution.
Saturated solution.
Okay, saturated, if I told you, it means full. Okay, it means full. When
Okay,
the
ma'am.
capacity is full, that means the solution is a saturated solution. Why do we say the
Yes.
solution is a saturated solution? See, better in solution, dissolving takes place. And how does dissolving takes place? Something like this. Yes or no? Something like this.
Yes, ma'am.
So obviously, are you able to relate it to that part? Why is
Yes,
the
ma'am.
concentration, why is the solution called as a saturated solution? If there's no
Yes.
capacity left for it to handle or dissolve other particles of the solute, yes or no?
Yes, ma'am. Okay.
So that is saturated solution. Now, a very important point is that saturated solution is at a particular temperature. Okay. Saturated solution is a function of temperature. It can also be said in this way. That means saturated solution is at a particular, is for a fixed temperature. Okay. For every different temperature, the saturated solution will be different. It will be different.
Okay.
That means, and why is it so? Can you tell me why is it so? Let's again take this example. Okay. These are two water molecules which could have hold maximum of 10 sugar particles. Okay. 10 sugar
Yes,
particles.
ma'am.
What happens? This was at a temperature of 30 degrees Celsius. Okay. 10 sugar particles. I increase the temperature to 58 degrees Celsius. Okay. Recall it from the
Oh,
first chapter. Temperature increase, velocity increase, movement of the particles will increase because the kinetic energy of the particles
yes.
will increase. Okay? If the kinetic
Will
energy will
increase.
increase,
Yes.
don't you think they will actually move something like this?
Yes, ma'am.
Now they are like this. Yes.
Yes,
Now
ma'am.
clearly they can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 sugar particles. Yes or no?
Yes, ma'am.
So with temperature, the saturated solution also differs. Saturated solution is a function of temperature. Is it clear?
Yes, ma'am. It
The
is
next
clear.
point is, so for every different solvent, for a specific solvent, let's call that as A, okay? For this solvent
Okay.
and for this solution, at different temperatures, the saturated solution will be different.
Yes, ma'am.
And the term which defines this is solubility. What is solubility, Harshitha?
It
Hmm.
sorry.
No worries. See, solubility means, beta, at 30 degrees Celsius temperature, two water molecules were able to have how many particles? 10? Yes.
And yes, ma'am.
So at 30 degrees Celsius, the solubility of those two water molecules is 10 particles. Okay. That means the amount the amount of solute that makes a solution saturated at a particular temperature is referred to as its solubility. Is it clear?
Okay.
The
So
7
if,
people that can fit inside the car is the solubility of the car. Okay.
okay.
Were
So
you
it is
saying
the
something?
amount of so it is the amount of solid present
Yes,
in
that can make
the
the solution saturated.
okay.
Is it clear?
Yes, ma'am. It is clear.
Solubility is again a function of temperature. Okay. So solubility of
Yes.
A at let's say 30 degrees Celsius is 10. At 50 degrees Celsius, it is 16. The solubility changes with the change in temperature.
Okay, ma'am.
Any problem in here?
No, ma'am. I got it.
Okay. Now, one very important point. If the solubility increases with the increase in temperature, clearly the solubility should decrease with the decrease in temperature. Yes or no?
Yes, ma'am.
Let's take one scenario. Okay, beta. Let's say
Okay.
we had a solution. Okay, we had a solution, and the solvent was what, 50 grams. Okay, the solvent was 50 grams, and in this the solute was 20 grams. Okay, the solute was 20 grams, and this 20 grams was the solubility at for this 50 grams solvent at 30 degrees Celsius temperature. Okay, that means this 20
Okay, ma'am.
grams of solute made this solution saturated at 30 degrees Celsius. Is it clear?
Yes, ma'am.
Obviously, if I increase the temperature, more than 20 grams of solute will make this solution as saturated.
Yes, ma'am.
Not understood. I repeat. If I increase the temperature, amount more than 20 grams will make the solution as saturated.
Yes, ma'am.
What happens, Harshita? Just think and then let me know. If I decrease the temperature to, let's say, 5 degrees Celsius,
Yes, ma'am.
what will happen then?
So if you decrease the temperature, the it won't be saturated. Like there will be pieces or particles which are submerged on the bottom.
Okay. Okay.
So it
Any other
would
point?
be saturated.
Sorry, repeat, beta. Not clearly audible.
So it would be unsaturated
It would be unsaturated. Why will it be unsaturated, beta?
because if we're decreasing the temperature means the space would become less, right? In the
See,
molecules.
unsaturated, let me just tell you, unsaturated means not full. Saturated means full. Clearly, unsaturated means not full. Okay, then can you say the same answer?
Um,
See, you are somewhere very right. You just use the term as not the correct one, but that's fine. See, what happens,
okay.
beta? Let's say, beta, at 5 degrees Celsius temperature, the water molecules will become something as close as this much, yes? Because the kinetic
Yes,
energy
ma'am.
will decrease, they will come close to each other, yes or no?
Close to each. Yes,
So
ma'am.
what will happen, beta? Now in this case, 1, 2, 3, 4, 5. Only 5 particles of sugar are there. Beta, this is just for the example. Please don't take it that only 5 or 2 molecules would be there. Okay, this is just for the
Yes, ma'am.
example part. Okay.
Okay,
So
ma'am.
now from 20 grams, okay, which let's say had what? 16 particles, okay, it has come down to 5 particles. 11 particles are left, yes or no?
Yes, ma'am.
What will happen is that the 11 particles will come out, the solution will keep on precipitating, the solution will keep on precipitating till the time the solution will attain saturation for that particular temperature. Example, what I mean by this is that the solution will keep on releasing the solute particles in the form of precipitate, which will settle down at the bottom of the container till the time the solution will be saturated for 5 degrees Celsius temperature. That means till the time there will be 5 sugar particles, the sugar solution will keep on releasing the particles. Is it clear?
Yes, ma'am.
Any problem in this?
No, ma'am. But ma'am,
I
how
hope.
does precipitation take place then?
Okay, see what happened, beta. Beta, let's say this is at 30 degrees Celsius, okay? 30 degrees
Yes, ma'am.
Celsius. For this, 16 molecules, 16 sugar particles can be there, okay? Okay.
Yes, ma'am.
So this is water. There are 16 molecules. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And this is all mixed with water, okay? This is all mixed with water. Now what happens,
Yes,
beta? Now what happens? See, If I say now it has been changed to 5 degrees Celsius and only 5 particles can be there, okay? Please pay attention what will happen. This is a container, okay? These are water molecules, very close. Yes or no?
Yes, ma'am.
Okay. These are sugar particles. 1, 2, 3, 4. Okay. Something like this are there. What will happen? Rest of them which are not with the water molecules, they will settle down here. Yes or no?
Yes, ma'am, they will.
Getting it? So this forms the basis of precipitation. This leads to the process of precipitation. Is it clear, beta?
Okay, ma'am.
I hope I am able to answer your question. Is it clear?
Yes, ma'am, it is clear.
Any other confusion related to this?
No, ma'am.
Fine. Coming on to the next top part, that is unsaturated solution. What do we mean by unsaturated solution, beta? Clearly, when the saturation is not soluted, and not saturated, yes?
Till the saturation, not till the
Yes.
saturation.
Yeah. So that means the solution is not saturated. We can clearly add more solute. And saturated solution is for a particular temperature. Let's say if we increase
Yes,
the temperature to 50 degrees Celsius, that means then solution is not not saturated. We can obviously add more solute. That makes the solution as unsaturated. Is it clear?
yes, ma'am, it is
Why
clear.
do we need to, let's say we are adding sugar to a container full of water, okay? In between, why do we need to heat it to add more sugar?
It's big. It's so when the temperature increases, the velocity also increases.
Very good. That means the solubility will also increase with the increasing temperature. If the solubility increases, clearly more amount of sugar could be dissolved. Very good.
Yes, ma'am.
But I would quickly want you to go through the NCRT, then we'll come on to the next topic. Okay?
Okay, ma'am.
Harshitha, any problem?
No, ma'am, I got it fully. Ma'am, can you hear me?
Yes.
Okay, ma'am.
Okay. See. Look here. What happened? At any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving. Yes. It is said to be a
Yes, ma'am.
saturated solution. See, it is also a function of temperature. That means it is dependent on the temperature. Is it clear? In other
Yes,
words,
ma'am.
when no more solute can be dissolved in a solution at a given temperature, it is called as a saturated solution. The amount of the solute present in the saturated solution at this temperature is called its solubility. Okay.
Solubility. Yes, ma'am.
Next point, very important. See, if the amount of solute contained in a solution is less than the saturation level, it is called as unsaturated solution, already discussed. Next point.
Yes, ma'am.
What would happen if you were to take a saturated solution at a certain temperature and cool it slowly? We have discussed this right now. The temperature will reduce, it will precipitate. Yes?
Yes, ma'am.
Tell me, is it clear bit at this point? This is specific point.
Yes, ma'am. I understood.
Next. We can infer from the above activity that different substances in a given solvent have different solubilities at the same temperature. Do you understand this point, beta?
Yes, ma'am.
What does this mean? Can you give me an example for this?
So
Look here, beta, look here. See, if I say I'm taking one solvent that is water, okay? Water.
okay, ma'am.
And I'm taking one temperature that is 30 degrees Celsius, okay?
Yes, ma'am.
I'm taking two different substances or solutes. Let's say one is sugar, okay? The
Okay,
other
ma'am.
is alcohol, okay?
Okay, ma'am.
So at 30 degrees Celsius, in the same amount of solvent, that is in the same amount of water, sugar dissolved will be different. Sugar dissolved to make the solution as saturated will be different. And the amount of alcohol dissolved to make the solution as saturated will be different. Why is it? Because clearly the substances are different. Is it okay?
Okay, ma'am.
Tell me, Harshita, honestly, is it understood?
Yes, ma'am. It is
Okay.
understood.
And now one very important point I wanted to point out here is that given solvent, see, We may say that the solution, the solute in the solution, all of that, okay, that with the increase in temperature, the solution saturation will change, okay. It is actually the solvent. Given amount of solvent at a given amount of, at a given temperature will decide the solubility. If I increase the solvent, clearly the amount of solution will increase. Clearly the solubility at that temperature will also increase. Is it clear?
Yes, ma'am. It is clear.
Coming on to the next point. Tell me any problem till here, or should we move on to the next point, beta?
We can move on, ma'am.
So we have discussed this. Now coming on to the concentration part. We have discussed the saturated part. Now we need to discuss, we told you that concentration and dilution, they are actually comparative terms. We need to understand that. Okay, see what happens.
Okay, ma'am.
If I need to calculate the concentration, okay, that means I need to actually calculate it in a mathematical way to give me the number of molecules or particles which are there in the given number of solvent, okay, given number of particles of solvent. So that on that basis, I'll be able to calculate the concentration of the solution. Fine. To calculate that, beta, we have three different methods. We have three different methods. What is that? First is mass by mass percentage. The second is volume by volume percentage. The third is mass by volume. Okay.
Okay, ma'am.
See, coming on to the first part, beta, that is mass by mass. We calculate the mass of a solute in a given solution. Okay. In a given solution. Let's say, beta, we have sugar. Okay. We have water. Okay. So both of these together will lead to a solution. Yes or no? Okay. To
Yes, ma'am.
calculate the concentration of this solution, I need to calculate the mass of sugar and the total mass of the solution. That means the mass of the sugar and water added. Okay.
Okay, ma'am.
Let's say the mass of sugar is 20 grams. Okay. The mass of the total solution is 100 grams. Okay. How do I calculate the percentage? 20 divided by 100. 20 being the mass of the solute, 100 being the mass of the solution. Okay. Into 100%. Why percent? Because obviously we are calculating it in the percentage units. 100 cancel gives you 20%. This is the concentration of solute in the solution. Is it clear?
Okay, ma'am.
Any problem
Yes,
in
ma'am.
here? Fine.
No, ma'am.
In the similar
I got
manners, we have it at your level. We will generally be using mass by mass percentage. Okay. But let's say, beta, let's
Okay.
say we have another, let's say 20 ml of solute is there. Okay. And 100 ml of solution is there. Total volume. Okay. Total volume. Be careful with this. Total volume. So 20
Okay.
by 100 into 100. Okay. It could have been 80 also. So if it would have been 80, I will be writing 80 here. Okay. So 4 gives you 25% as the concentration. Is it clear?
Yes, ma'am. It is
This
clear.
simply gives you out of, see beta, please understand one thing. I don't know, you would be knowing it better, but see what happens. When we calculate this in the percentage terms, okay, when we calculate this in the percentage terms, we actually limit it to 100. And through that, we get to know an idea. Example, in the above example, when we have, let's say in this example, 80 ml, okay, 80 ml of volume, okay, of the solution. Out of this 80 ml, this forms the 100%, okay. So from this 80 ml, 25% of volume, okay, will be of the solute. We can calculate that. You getting that? Yes or no? So
Yes,
we
ma'am.
actually take it as a whole of 100. Why? Because obviously we are multiplying it with the 100%. Is it clear? Even if it's
Yes.
greater than 100, even if it's less than 100, we get an idea from the total of 100. Is it clear?
Yes, ma'am. It is clear.
The third one is mass by volume, generally not talked about in your syllabus, but just to discuss mass by volume, mass of the solute, okay, mass of the solute and volume of the solution, never the solvent, okay,
Okay, ma'am.
into 100%. That's it. Okay, Harshita.
Yes, ma'am.
Quickly, we'll go for some questions. Please go solve this example 2.1.
Yes, ma'am.
Is the screen visible? Yes, it is.
Yes, ma'am, it is visible.
I'm opening some questions for you till the time you solve this.
Okay, ma'am. Ma'am, is it 11.1 percentage?
Just a second, but I'm just going through the question.
Okay, ma'am.
Yeah. Yes, Harshita. What are you saying, Beta?
It's
Let's see that. Yes,
11.1.
your answer. 11.1% exact. Fine.
Yes, ma'am.
So first, I hope you have calculated the mass of the total solution given the by the given masses of
Yes,
solute
ma'am.
and the solvent. Yes,
Yes, ma'am, I have.
wonderful. Now see. Now these are very simple type of questions, Harshita. Okay. I'm going to
Okay,
actually share some of the questions with you which have a different approach. Okay. Let's quickly go through them.
sure, ma'am.
See. Visible? Yes, it should be.
Yes, ma'am, it is visible.
See what happened, beta. Go through this question one beta here.
Okay, ma'am.
Done?
Yes, ma'am.
See what happens. I'm quickly going to share the concept of this. What happens, beta? In case of the mass by mass solution percentage, okay, either we are given the mass directly, that is the best part. That is the simplest method, okay. The second
Yes,
method can be using percentage terms, okay. Now that can also be done in the two ways, okay, beta. First is percentage of the solute is given, okay, is given, and mass of the solution is given. I'm giving you the two scenarios that are generally there. Mass of the solution is given. Now, if I ask you to calculate Now, if I ask you to calculate the, the mass by mass concentration, will you be able to do that?
Um,
I'll give you one example for this. See here, beta. If I say 35% of the solute is there, okay? 35% of
yes,
the solute, and 150 grams is the mass of the total solution. Now
yes,
calculate the mass by mass concentration, okay? Percentage. What will you do in this case, beta?
we should divide the 35 and 150 into 100 percentage.
See, exactly, that's the right thing. What we need to do is that we need to know the mass of the solute and the mass of the solution. We already know the mass of the solution, yes? What we
Yes,
need
ma'am.
to know is the mass of the solute. So obviously 35% of 150 grams, we'll calculate it. Once we have calculated that, we can clearly solve the example. How we will do this? 35 by 100 into 150 grams, yes?
Yes, ma'am.
What will be the answer? 2, 3, 35 into 3 divided by 2, okay? Let's just calculate it. But after that, once we have gotten, let's say we have some 75 grams. Let's assume that, okay? We'll take 75 by total of 150 into 100. Yes or no?
Yes, ma'am.
Right? So this is one method. But at the second method, please pay attention here. The second possibility is that the percentage of the solute is given. Harshita, am I going very fast? I think you are writing.
No, no,
Okay.
ma'am, it's okay.
Yeah, the percentage of the solute is given, but no mass is given, nor of the solute, nor of the solution. Okay. Neither of the
Okay.
solute, nor of the solution, nor of the solvent. But mass
Yes, ma'am.
is not. Now, what will you do? Now, let's say, example, beta, 35% solute is there. Okay. 35% solute is there. Tell me the mass of the solvent, and then just tell me the mass of the solvent and the total solution. That's it. What will you do here?
Okay. S- so we have to divide the 35 percentage with 100.
Okay. Then
Um,
if we divide it by 100%, we will just be able to remove the percent sign. Yes. That is the
yes, ma'am.
mathematical part, right? But we multiply it by what? 35% of what? Earlier in the earlier part, we saw that 150 grams was the total mass of the solution. So 35% of
Yes,
the total mass of the solution, we calculated it. Yes or no?
yes, ma'am.
Okay. Now, I just now asked you to read one question. That question is like this. Okay. Do you remember that question? I'm sharing that question again so that you are able to understand it better.
Yes, ma'am.
See, this first question. If you read it clearly, just read the first question and not the options better. Okay. So clearly
Okay.
we have been just given the mass of the solute in the percentage form. Yes.
Yes, ma'am.
Now, if I ask you, can you tell me the mass of the solute here, the mass of the solvent here, and obviously the mass of the solution through just the question part?
Yes.
See, better what happens when I just now told you we multiplied by 100% to get it out of 100. Okay. When the
Yes, ma'am.
percentage is given, and no mass of the solution or the solvent is given, we assume it that 35% of the 100 grams. We assume the solution to be total of 100 grams. Okay. Since we are
Okay,
talking
ma'am.
in terms of mass, we assume it to be a total of 100 grams. Then if I say that 35% of solute is given, clearly 35% of the 100 grams of the solution. Is it clear?
Yes, ma'am.
So therefore, 35% of solute, if it's given and no mass of the solution is given, that means it will mean that 35 grams of solute in 100 grams of solution. If 35 grams of solute is there, that will give me 65 grams of solvent, total of 100 grams of what? Solution.
Solution.
Beta, tell me, is it understood? If 35%
Yes,
of solute is there, clearly the rest 65% will be the solvent. Yes.
yes, ma'am.
And 65% and 35% of what? Of 100% in total. Is it clear?
Yes, ma'am. It is clear.
Tell me, is it clear? Now, can you please solve the first question that's given here?
Okay, ma'am.
See, 0.01% by mass. can you tell me what do we mean by this 0.01% by mass? Can you tell me the mass in grams of the solute of sodium chloride?
Is um
Say, beta, say, look here,
yes.
look here. And
Okay, ma'am.
don't get confused. Is the screen visible now?
Yes, ma'am, it is visible.
Okay, fine. See, look here what happened. But that question is saying 0.01% of solute, that is sodium chloride. Okay, that's it. By mass. Clearly, if it's given by mass, we're talking about mass. See, at your level, we generally have the mass by mass part. Okay, so don't get confused with that. Okay.
Yes, ma'am.
Now, can you tell me this is the percentage of the solute in the solution? Okay, no mass of the
Yes,
solution is given. Can you tell me from this what will be the percentage of the solvent? Just the percentage of the solvent?
of uh
Yes, beta, 99.99%. Overall, it's 100%.
okay,
I
ma'am.
can just subtract this value of solute percentage from the 100%.
Yes, ma'am.
Beta, getting it? Yes or no?
Okay, ma'am.
Confused.
So I
A
have
bit
to subtract
confused.
that percentage with
See,
100.
see. Look here. Beta, total is a solution. Yes. Solution has solute and a solvent. Yes or no?
Yes, ma'am.
So total is 100% always. We know it. Even if we talk it in
Yes,
terms of percent, total is 100%. Yes. So
yes,
if
ma'am.
the solute is 0.01%, how will I get to know the percentage of the solvent? Should I not subtract this given value from the total, which is 100%?
Yes, ma'am.
Getting
Yes,
it?
ma'am.
Yes or no?
Yes, ma'am.
So now can you tell me the percentage of the solvent here?
Yes, ma'am. So it is 99.9%.
First, is it clear?
Yes, ma'am. It is clear now.
Now can you tell me the mass of the solute and the solvent here, beta?
Yes, ma'am.
Tell me.
It so it would be
See, beta, in this
like,
situation, we assume the total mass also to be 100 grams. Okay.
okay, ma'am.
So if it is 0.01%, that means we will, yes or no? 100,
Yes,
100
ma'am.
cancel, gives you 0.01 grams. Yes or no?
Yes, ma'am.
And in the similar way, it will give you 99.9 grams. Clear or not?
Yes, ma'am. It is clear.
So now can I say that this solution of sodium chloride and water has got 0.01 grams of sodium chloride dissolved in 99.9 grams of water.
Okay, ma'am.